So hi children, how are you all? I hope all you fine. So children, I hope all you who followed that previous conditional identity videos. So here in this video, last three identities I told you, no, three identities left over. So here ninth identity is sin A plus sin B plus sin C. So children, up to now we discussed that sin 2a cos 2a as well as sin square a cos square a. So here the formula related to sin a plus sin b plus sin c is equal to 4 cos a by 2. Why? Because here a is there, no, so that's why a by 2, submultiple angles. Okay, so cos a by 2, cos b by 2, cos c by 2. And the condition we know that a plus b plus c is equal to 180 degrees. So here from this one, take that LHS ma. So in that LHS, what is that? Sin A plus sin B plus sin C. Okay. So which is equals to sin A plus sin B plus sin C. So sin A plus sin B, how we can write that? Sin C plus sin D formula, what is that? Sin C plus sin D, which is equals to 2 sin C plus D by 2 cos C minus D by 2. Okay, so that formula right here, 2 sin A plus B by 2 into cos A minus B by 2. Okay, plus sin C. So sin theta formula we know that. So sin theta is equal to sin 2 theta. So sin 2 theta is equal to 2 sin theta cos theta. So here sin theta is equal to 2 sin theta by 2 cos theta by 2. Clear ma? So here plus 2 sin C by 2 cos C by 2. Okay, 2 sin C by 2 cos C by 2. Clear? So from this one, here a plus b by 2, a minus b by 2 angle, no, and here a plus b plus c is equal to 180 degrees. That condition we know that. So see here, a plus b is equal to 180 degrees minus c. Okay, but here we are having a plus b by 2, a minus b by 2, like that, by 2 is there, no, so that's why both sides also divide by 2. Both sides also divide by 2. So from this one, a plus b by 2 is equal to 180 degrees by 2 minus c by 2. Okay. So from this one, here we can write that or 90 degrees minus c by 2. Understand ma? Why? Because here both sides we divide with 2. Okay. So that's why 180 by 2 is equal to 90. No? So that's why here we written that 90 degrees minus c by 2. Am I clear to you? So here, see, 2 sin, so a plus b is equal to 90 minus 90 degrees minus c by 2 into cos of a minus b by 2. Okay, plus, and here 2 sin. Okay, so as it is right here, later we will write that cos c by 2. Okay, so from this one, 2 sin 90 minus theta. So 90 minus theta means first quadrant. So in the first quadrant, all the trigonometric ratios are positive. Okay, and here 90 is there, means sin become as cos. Okay, so 2 cos of c by 2, 2 cos of c by 2 theta into cos of a minus b by 2. Okay, plus 2 sin c by 2 cos c by 2. Okay. So from these two terms here, cos c by 2 and here also cos c by 2 and 2 also in common. So take that 2 cos c by 2 as common. 2 cos c by 2 as common. So here the leftover cos of a minus b by 2 plus, and here the leftover sin c by 2. So children, sin c by 2. So here c by 2, how we can write that? A plus b by 2 is equal to 180 degrees minus c whole by 2. And in the same way, here see that 2 cos c by 2, 2 cos c by 2 into here cos of a minus b by 2, cos of a minus b by 2 Okay, plus sine of c by 2 is there, no? So here a plus b, which is equals to 180 degrees minus c, and in the same way c is equal to 180 degrees minus of a plus b also we are writing, no? Okay, so here a plus b by 2 is there, so that's why both sides also divide by 2. Now here c by 2 is equal to 90 degrees minus of a plus b by 2. Understand, ma? So at the place of c by 2, here we can write that 2 cos c by 2. Here don't change that. Cos of a minus b by 2 plus sin c by 2. So sine of, at the place of c by 2, 90 degrees minus of a plus b by 2. Okay, so from this one, 2 cos c by 2 into cos of a minus b by 2 plus sin 90 minus theta. So sin 90 minus theta means first quadrant, we know that, and here sin is become as a cos. So cos of theta is a plus b by 2, and all the trigonometric ratios are positive, no? Okay, so that's why. So which is equals to 2 cos c by 2 into cos of a plus b plus cos of a minus b. Okay, so here a minus b plus cos of a plus b by 2. So here cos of a plus b plus cos of a minus b formula, what is that, ma? Which is 2 cos a cos b. Okay, and here by 2 is there, no? So that's why here a by 2 b by 2. Understand? So that formula right here, 2 cos a by 2 cos b by 2. Okay, now here after multiplication, 2 into 2 is 4 cos a by 2 cos b by 2 cos c by 2. Am I clear, children, here? Yes. So here this is the proof. So which is equals to sin a plus sin b plus sin c is equal to 4 cos a by 2 cos b by 2 cos c by 2. Okay, that's what we got here. Okay, ma. So this is that 9th conditional identity. So let us see the 10th conditional identity. So here 10th conditional identity, see here. So sin a plus sin b minus sin c. Okay, sin a plus sin b minus sin c, which is equals to 4 sin a by 2 sin b by 2 cos c by 2. Okay, this one we need to prove that. Okay, so children, see that proof. Okay, so take that LHS. So what is that LHS, ma? So the LHS is sin a plus sin b minus sin c. Okay, sin a plus sin b minus sin c. So here sin a plus sin b. So what is that formula here? Sin a plus sin b. How we written that? That is 2 sin a plus b by 2 into cos a minus b by 2. A minus b by 2. And here we know that a sin c formula. What is that sin c formula? Just previous we written, no? That is 2 sin c by 2 cos c by 2. Okay, again simplification is same, but here only the symbol is changed. Okay, ma. So from this one, here we can take that 2 sin of, here a plus b by 2, what we can write here? 90 degrees minus c by 2. Okay, why? Because a plus b by 2 is equal to 180 degrees by 2 minus c by 2, or c by 2 is equal to 180 degrees by 2 minus of a plus b by 2. Okay, any formula we can use that is related to, if a plus b is there, then we have to go for that c. If c is there, means we have to go for that a plus b. Okay, into cos of a minus b by 2 minus 2 sin c by 2 cos c by 2. Clear? So which is equals to 2 sin 90 minus theta. So that one become as cos theta. So 2 cos 2 by 2 cos of a minus b by 2 minus 2 sin c by 2 cos c by 2. Okay, so from this one, here we can take that 2 cos c by 2 as common. Okay, so 2 cos c by 2 as common. So here cos of a minus b by 2 minus, and here see that cos c by 2 as common, no? So what is there? Still we have left here sin c by 2. Clear ma? So from this one, which is equals to 2 cos c by 2 into, here cos of a minus b by 2, cos of a minus b by 2, and here minus sin, at the place of c by 2 we can write that 90 degrees minus a plus b by 2. Understand? So from this one, 2 cos c by 2 is into cos of a minus b by 2, and here 90 minus theta. So 90 minus theta means that is sin become as cos. So minus cos of a plus b by 2. Understand? So here cos of a minus b minus cos of a plus b. So cos of a minus b, cos of a minus b minus cos of a plus b. What is that formula here? First a minus b is there, no? So that's why positive. So 2 sin a sin b. So here by 2 is there, no? So that's why a by 2 b by 2. Understand? So from this one, 2 cos c by 2 into 2 sin a by 2 sin b by 2. Okay, so from this one, 2 2's 4 sin a by 2 sin b by 2 into cos c by 2. Hence it is proved. Okay, so this is the 10th conditional identity. Understand ma? So here what is the 10th one? Here sin a plus sin b minus sin c is equal to 4 sin a by 2 sin b by 2 cos c by 2. Okay, that's what we got here. Okay, so this is the 10th conditional identity. Now we will discuss that last conditional identity, that is 11th conditional identity. Cos a plus cos b plus cos c, which is equals to 1 plus 4 sin a by 2 sin b by 2 sin c by 2. So see here proof. Okay children, so see here again LHS. What is that LHS? Cos a plus cos b plus cos c. Okay, that is the LHS. So here cos a plus cos b. So cos c plus cos d formula, what is that ma? 2 cos a cos b. So 2 cos of a plus b by 2 into cos of a minus b by 2. Okay, that is the formula for that, cos a plus cos b plus cos c. So cos c is equal to formula in terms of sin. Why? Because this formula every term is in that sin, no? So that's why. So 1 minus 2 sin square c by 2. 1 minus 2 sin square c by 2. So 1 minus 2 sin square c by 2. Am I clear to you? Yes. So which is equals to 2 cos of a, at the place of a plus b by 2 we can write that 90 degrees minus of a plus b by 2. Sorry, 90 degrees minus of c by 2 into cos of a minus b by 2. Okay, plus 1 minus sin square c, sorry, 2 sin square c by 2. Okay, so from this one 2, and here 90 minus theta, so we know that again that is positive only, but here cos changed as a sin. 2 sin c by 2 cos of a minus b by 2 plus 1 minus 2 sin square c by 2 2 sine square c by 2. So from these two terms, here we can take that 2 sine c by 2 as common. So 2 sine c by 2, take it as common. So here leftover ones, cos of a minus b by 2, and here we taken 2 sine as common, no, so minus sine c by 2, and here plus 1 is there, no, so write here plus 1. Am I clear, children? So from this one, plus 1 I am writing here, 1 plus 2 sine c by 2, 1 plus 2 sine c by 2 into cos of a minus b by 2, cos of a minus b by 2 minus sine of c by 2. At the place of sine of c by 2, we can write that 90 degrees minus of a plus b by 2. Okay, already we know that how to write this. Okay, so which is equals to, okay, 1 plus 2 sine c by 2 into here cos of a minus b by 2 minus here 90 minus theta, so cos theta a plus b by 2. Understand? So here 1 plus 2 sine c by 2 into cos of a minus b minus cos of a plus b. So what is that formula? 2 sine a by 2 sine b by 2. Understand? So from this one, 1 plus 2 to 4 sine a by 2 sine b by 2 sine c by 2. Okay, so 1 plus 4 sine a by 2 sine b by 2 sine c by 2. Clear? So hence it is proved or not? So 1 plus 4 sine a by 2 sine b by 2 sine c by 2. So this is that 11th conditional identity. So children, I am telling you that this is the last conditional identity. Why? Because I am saying last means here you can apply that here minus at the place of cos c before, and here also you can take that minus cos b. Okay, so you can create that more identities related to this one, but main identity is completed. Okay, main 11 identities we discussed in these videos. Okay, so children, up to here transformations concept completed. So in the transformations we have that 2 worksheets. So in the next video we will discuss that problems from worksheets. Okay, thank you all.